Alrighty, now on to the second topic of the day. So we're graphing a parabola of the form f of x equals ax squared plus bx plus c, integer coefficients. So when you graph, the most straightforward way always is to plug in values. So if I see f of x, then you can just plug in values. However, remember when we graph parabolas, we need to find the vertex first, right? And then how do we know, how do we find the vertex? We have to use the vertex form. So what is that? That is y, or it's f of x, it doesn't matter. Okay, this is equal to a, x minus h quantity squared plus k. And the vertex is hk, right? So, but you can't see that right away looking at just this when it's in this form, right? So what is our goal going to be? Our goal is to rewrite this quadratic equation into vertex form. So in other words, we're going to turn that to make it look like vertex form. Okay, so I gave you guys some steps, but to implement these steps, I'm just going to do an example so you guys can see. So I'm going to do 2 because I know that changing forms can be a little tricky. So yeah, the first example that we're going to look at is y is equal to negative x squared plus 4x minus 2, right? And then what is step 1? Step 1, it says factor a from the variable terms. So what do I mean? So it's over here. So we're ignoring the c and we're just factoring it out of the terms that have variables. So in this case, a is negative 1, so I'm going to factor out that negative, and if I do that, I get x squared minus 4x, and then I'm just going to leave this negative 2 out here, right? And if I distribute that negative 1 back in, I'm left with my original problem, right? So I didn't change anything. What is step 2? Step 2, I want to complete the square within the parentheses. So what does that mean? I'm going to add and subtract the b over a times divided by 2 quantity squared. Dividing by 2 is also the same as multiplying by 1/2. And I'm only going to do that within the parentheses. So why do I want to complete the square? My goal is to make this look like a times the quantity x minus h quantity squared. So we know that this has to be squared somehow. How do we do that? We're going to complete the square. So step 2, that's what we're going to do. So I'm going to take this term, so the linear term. Okay, when you do complete the square, you always look at that linear term. The coefficient in front of it is negative 4, so negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. All right, so let me show you. So negative 4 divided by 2 quantity squared. That's what I did. So this is negative 2 squared, which is 4. Right? So you can do it in your head, all right? Just like what I did, but I decided to show you guys what I'm doing. Right? So now what am I going to do with this 4 that I found? I'm going to do that trick. So I'm going to add 0 to my function, right? So it doesn't change anything. So I know I want a 4. So how do I balance this out? I also have to subtract 4. All right, so it's like when you do when you just have fractions, we always multiply the fraction by 1, right? In this case, when you have functions like this, the best way is to add 0 when you want to change it a little bit, right? Just to make it better, to work better in our favor. So now what are we going to do? So for step 3, we're going to apply the distributive property and remove, that's a typo. Remove this term. So remove the one that you subtracted, the one that you subtracted. So what do I mean? I'm going to take this and I'm going to distribute it into this so I can take it out. And then what am I left with? I'm left with y is equal to negative and then x squared minus 4x plus 4. These stay in the parentheses because I did not distribute anything into them. right? Then I'm left with plus 4 minus 2. Okay, so now, step 4, we are going to factor this trinomial. So just like completing the square, if you did it correctly, this should be a perfect square trinomial. If it's not a perfect square trinomial, something went horribly wrong, and we need to fix it, right? So, but in this case, we are left with a perfect trinomial, and it factors to x minus 2 quantity squared. Okay, so I'm actually going to combine step 4 and 5, okay, because we can easily do that because I can always add. So why take an extra step to add 4 and negative 2? So I get plus 2, right? So this is the exact same as this in vertex form. How do I make sure that this is correct? So what are we going to do? We can expand it. So this becomes x squared minus 4x plus 4 plus 2. This is equal to negative x squared. I'm distributing plus 4x minus 4 plus 2. And this is equal to negative x squared plus 4 minus 2. This is the exact same, right? So, but what if you don't get that? But you were still able to, but you checked the inner parentheses and it was still a perfect square. That means something went wrong between step 2 and step 3. You might have forgotten to distribute the a into it, might have done something with the signs. So there's multiple things that could have happened. But yeah. So that's just a big thing. So if you don't get the same coefficient, that's supposed to be an x. If you don't get the same coefficient, then or the same constant, sorry, then usually it's going to happen between the second and third step. Right? So let's see. So our goal is to graph. Just to save time, I'm not going to graph it, but I will talk about what the graph what would our points be, right? And then I'll let you guys graph it in your own time. So first of all, what is our vertex? Our vertex is HK. What is HK? HK is 2, 2. Okay, so that's always going to go in the middle. And how do I know which x's to pick? I'm going to pick two x's that are less than 2 and two values that are bigger than 2. Right? And then to find these y values, you're just going to plug it into your function, and then you'll get your f of x. But I will let you guys do that on your own time. Right? So now let's do example 2. Okay, so we can get used to this process hopefully. So now we want to solve for y equals 2x squared minus 12x plus 16. Right? So our goal is to put it in vertex form. The reason why we want it in vertex form is so we can graph our function. So essentially, so we know what points to plot. Because if we don't do that, so for example, if our graph look, let's see, we normally pick -2. So for example, say our graph kind of looked like this, right? But if we pick -2, 1, 0, 1, 2, as you can see, we're only increasing. We don't see when the graph flips, when it starts increasing. So that's why it's really important to know where the vertex is. So you don't have to keep plotting points until you finally see when the graph increases. So it's just better to find the vertex first and then pick 2 points bigger than it and less than it. All right? So that is why we put it in vertex form. So now let's do example 2. I'll put the steps up here again so we can see. So the very first step, so essentially what we're doing is our goal is to complete the square, right, on the variable term. So in order to do that, the very first step for completing the square, okay, so I'm just going to put equals because it's the same. We want our a to be 1 when we complete the square. So I'm going to factor out this 2, and I'm left with 2x, or I'm left with x squared minus 6x, but do not do anything with this constant. Right? So checking our work, we get the same as above. Now we want to complete the square. So what to that? So x squared minus 6x. I'm going to take the coefficient of this linear term, which is negative 6, and we're going to divide it by 2 and then square it. When we do that, we're going to get 9. So I want to add 9, but how do I keep my equation balanced? I also have to subtract 9. If I don't subtract 9, then my equation is going to be, it's like a seesaw. Like it's going to be tilted, but we don't want that. We want it to be balanced. Right? So we got to add 0. So when I add 9 subtract 9, when we combine these, it's going to be 0, and our function doesn't change. Right? So before we can complete the square, there's this little term right here that we need to get rid of. How are we going to get rid of it? We're going to take this 2 and we're going to multiply it into negative 9 to just kind of kick it out of our parentheses. So this is going to be 2 and then x squared minus 6x plus 9. And then 2 times negative 9, that is negative 18 plus 16. Right? So now we can, so step 5 and 6, I'm going to factor, and or 4 and 5, I'm going to factor and simplify. So this is a perfect time to check if you did completing the square correctly, because you should be left with a perfect square trinomial. And we are, because I can do x minus 3 quantity squared. Right? And then negative 18 plus 16, that is minus 2. Okay, so this is this. These are the exact same, but this one's in vertex form. So to double check our work, let's kind of work backwards. Right, so this is going to be 2, and then this is x squared minus 6x plus 9 minus 2. This is 2x squared minus 12x plus 18. Minus 2, and then this is 2x squared minus 12x plus 16. As you can see, this is the exact same as over here. So we know that this is the true vertex form, right? So now, okay, again, I'm not going to graph, but I will talk about it. So now what is the vertex? The vertex is HK. HK is 3, negative 2. Okay, so now that we know our vertex, we can now pick our x's to find our y's. Okay, so remember the vertex is always in the middle, so this is 3, negative 2. And how do we find the other 4 values we need to pick? We're going to pick 2 that are less and 2 that are greater than x. So this is 1, 2, and then 4, 5. And then you just plug in these values into here. You can also do it to the first one, but this is their equivalent. I personally think it is easier to plug in x once as opposed to twice. Right? That's just more to keep track of. So I would normally do it here, but it's up to you on what you want to do. Right? So this is how you rewrite a quadratic equation into vertex